put 0 degree Celsius into the Kelvin, you have to convert. Put Tc equal to 0, 0 by 100 equal to 0. Tk minus 32 is equal to 100 into this 0. Then Tk is minus 273 equal to 0. Tk equal to 273 Kelvin. That means 0 degree Celsius is equal to 273 Kelvin. In this way, by using this temperature scale system, we can convert Celsius scale into Celsius into Fahrenheit, Celsius into Kelvin, Fahrenheit into Celsius and Fahrenheit into Kelvin, and Kelvin temperature into Fahrenheit and Kelvin into Celsius also. Keep this equation into the mind, most important equation. Tc by 100 equal to Tf minus 32 divided by 180, because 180 parts are there, which is equal to Tk minus 270 divided by 100. In this way, one temperature can be converted into another temperature scale by using this equation. You can put the known temperature with a scale and convert into the equivalent form, but we have to keep this equation into the mind. In another way, you can cancel 1 0 from all the denominators. You can write Tc by 10 equal to Tf minus 32 divided by 18 equal to Tk minus 270 divided by 10. Again you can divide it by 2, then Tc by 5 equal to Tf minus 32 by 9 equal to Tk minus 273 divided by 5. You can write like this, or you can write Tc equal to Tk minus 273, because 100 denominator is same, therefore Tc equal to Tk minus 273. In this way, when you have to convert any temperature into its equivalent form, you write that equation Tc by 100 equal to Tf minus 32 divided by 180, which is equal to Tk minus 270 divided by 100. And if you have to convert Celsius into Fahrenheit, write only these two quantities. If you have to convert Fahrenheit into Kelvin, write these two. If you have to convert Celsius into Kelvin, write only these two. Put one value, put the mathematical value, and you will get the equivalent conversion. In this way, you can convert Celsius scale into Fahrenheit, Fahrenheit into Kelvin, Celsius into Kelvin, Kelvin into Celsius and Fahrenheit. Any temperature can be converted into its equivalent form. And all the three temperature scales are decided by taking melting point of ice and boiling point of water. Now, after the discussing about the temperature scales, now we are going to some modes of transmission of heat. First mode of transmission of heat is the conduction. If you consider any solid rod, and if you hit the solid rod at its one end, then particles into the solid, they will absorb the heat energy at its one end, then they will they will transfer the heat energy from one end to another end, or one region to another region. But in this transmission process, particles are not moving from its one region to another region. Particles are steady. They are only supplying the heat to the next group of particles. The next group will provide the heat energy to the next group. But in this transmission process, particles are not moving physically. Only transmission of heat energy takes place from one region of a body to another region. It is called as the conduction. Conduction takes place in a solid only. That means if you hit the solid rod, then heat energy will transfer from one region to another region without bodily movement of particles. Any cooking utensils, if you put on the heater, heat energy will be absorbed at its base, and it will be transmitted from lower base to upper region. That means in this transmission, no particles are moving. If you hit any solid rod, then heat energy will flow from one end of the rod to the another end, but particles are not moving. Particles are steady. Only the heat energy will be transmitted by them to the another region. That means conduction is the process of transmission of heat, in which transmission of heat energy takes place from one region to another region without bodily movement of particles. Try to understand once again. Conduction is the process of transmission of heat in which heat energy transfers from one region to another region without bodily movement of particles. Without bodily movement of particles. It is called as the conduction. Conduction takes place in a solid body. If you hit any solid body, then transmission of heat takes place from one region to another region without bodily movement. This is called as the conduction. Cooking utensils, boilers, calorimeters, these are the examples in which transmission of heat energy takes place by the process of conduction. Heat energy will transfer from one region of a body to another region without actually movement of particles. Try to understand. Conduction is the process of transmission of heat from one region of a body to another region without bodily movement of particles. That is called as the conduction. Now what is the convection? Convection takes place in a liquid basically. Now convection is the process of transmission of heat in which transmission of heat energy takes place from one region to another region by actual movement of particles. If you take water in a pot and if you keep that pot on a heater, then heat energy will be absorbed initially by the molecules of the water present at a base, and after absorbing the heat energy they will physically move from one region to another region. They are physically moving from one region to another region, means hot molecules are going up due to decrease in density, cold molecules are going down, again they will absorb the heat energy, then they will come up, cold molecules will go down, and after certain time temperature of entire water will become constant. Is it? That means in this process, in the convection process, when the particles or molecules they will absorb the heat energy, they are moving physically. In the liquid, you know, you will observe that if you keep the water into the pot and if you start the heating, molecules are moving, hot molecules are coming upward, down, or cold molecules are going downward. You will observe that. That means process of transmission of heat energy takes place by actual movement of particles, actual movement of molecules, then it is called as a convection. Convection is the process of transmission of heat in which heat energy will transfer from one region to another region by actual movement of particles or by actual movement of molecules. This is called as the convection. Convection takes place basically in a liquid. That means when you heat the liquid, molecules or particles are moving from one region to another region, therefore it is called as a convection. And examples, you can say sea and land bridges, or one can say ceiling factories, etc. These are the examples of the convection. Or if you keep water on a heater, then water molecules will move from one region to another region. This is the process of convection. Convection takes place on a solar water system also. That means when sun radiations will be bombarded on the water panel, heat energy will be absorbed by the water, and density of water decreases, and hot molecules are going upward, cold molecules are going downward, and transmission of heat takes place by the process of convection. Now we are going towards the radiation. Radiation is the process in which transmission of heat energy takes place in the form of electromagnetic waves, in the form of rays from one region to another region without any medium, or this transmission can be performed, this can be carried out in gas also and in air also. Sun radiations are coming from sun on surface of earth, we are getting heat. This is in the form of radiations. Initially sun radiations are coming from space, vacuum, then air, and then on the surface of earth. That means transmission of heat takes place through all the mediums, that means air and vacuum and one can say space. Therefore in this process there is no need of any medium. Without any medium also heat energy can be transmitted, but transmission of heat energy takes place by or in the form of electromagnetic radiations or in the form of rays. Therefore it is called as a radiation process. This process takes place in vacuum as well as air. That means basically this is a very fastest process of transmission of heat. In fractions of second we are getting heat energy from sun. That means radiations are coming with we know velocity of light is 3 into 10 to the power 8 meter per second, 3 into 10 to the power 8 meter per second. By this fastest speed radiations are coming on surface of earth and we are getting the heat energy. This is the very fastest process of transmission of heat. That means heat received from sun, heat received from fire. We are if you are at a stationary position near to the fire, we are getting the heat in the form of radiations. That means these are the examples of radiations. That means we have studied three modes of transmission of heat: conduction, convection, and radiations. First, see, conduction is the process of transmission of heat in which heat energy transfers from one region of a body to another region without bodily movement of particles. That means, for example, heating of solid. Then convection is the process of transmission of heat in which heat energy transfers from one region to another region by actual movement of particles. And radiation is the process of transmission of heat in which heat energy transfers from one region to another region, one point to another point without any medium, with, one can say, in the form of electromagnetic waves. This is called as the radiations. For example, heat energy getting from sun, which is in the form of rays, electromagnetic rays, and this is, one can say, process of radiations. That means transmission of heat energy takes place by three modes: conduction, convection, radiations. Conduction takes place in a solid, convection takes place in a liquid, and radiations takes place in a gas, vacuum and air also. That means you can define or you can distinguish these three processes of transmission. Conduction is the process of transmission of heat in which heat energy transfers from one region to another region by without actual movement of particles. In convection, heat energy transfers from one region to another region by actual bodily movement of particles, and convection is the process in which heat energy transfers in the form of electromagnetic waves. Conduction is a slow process of transmission of heat. Convection is also moderate process, but radiation is the fastest process of transmission of heat. Conduction takes place in solid, convection takes place basically in liquids, radiations takes place in air, gas and vacuum also. For example, conduction, any cooking pot, if you heat the pot at its base, then heat energy will transfer from lower base to higher base, upper base, one can say conduction takes place. Convection, if you heat the water, then hot molecules are coming on surface, cold are going down, one can say convection. And radiation is nothing but we are getting the heat energy from sun radiations in the form of waves, is it? That is called as the radiations. In this way you can distinguish conduction, convection and radiations. These are the three modes of transmission of heat. Now after modes of transmission of heat, we are coming across the conductors of heat. What do we mean by good conductors of heat and what do we mean by bad conductors of heat? Good conductors means what? The material or body which conducts heat easily from its one region to another region, called as a good conductor. Once again, the material or body which conducts heat from its one region to another region easily. For example, iron, copper, silver, gold, etc. All these are the good conductors of heat. That means if you heat one region of the such type of bodies, then the heat energy will be transmitted to another region easily. Then it is called as a good conductor. The material which conducts heat energy from its one region to another region is called as a good conductor. And bad conductor means what? The material which does not allow transmission of heat from its one region to another region easily. For example, wood. You cannot transfer the heat energy from its one region to another region in case of wood. In case of wool also, you cannot transfer heat energy from its one region to another region. Therefore, it is used in different types of the thermal insulating materials, into the different thermal insulators. Wool is used for that purpose. Glass is also semi bad conductor. You cannot transfer the heat energy 100% from its one region to another region, but it is a, one can say, semiconductor of heat, not exactly bad conductor. Thermocol, you cannot transfer the heat energy from its one region to another region. That means wood, wool, thermocol, these are the examples of bad conductors of heat. That means once again we will define good conductor of heat can be defined as it is the material or body which conducts heat energy from its one region to another region easily. Iron, copper, silver, gold. Bad conductor of heat is defined as it is the material or body which does not conduct heat energy from its one region to another region. Wood, wool and thermocol. Glass is coming under semi-conducting property. You cannot give into the bad conductor this example, but good conductors and bad conductors are classified basically according to this criteria. We know glass is semiconductor, that's why we are getting heat energy from sun, and sun radiations can be passed from the glass, and we will get heat from the glass also, but it will be blocked into the one can say by glass into certain proportion, but glass can transfer the heat energy from radiation process. After transmission, after good conductors and bad conductors, now we are going towards law of thermal conductivity. This one is the most important article. If you consider one solid body or solid rod, and if you heat the solid rod at its one end, then what will happen? Initially, without heating or without starting the process of heating, temperature of entire rod is constant. This is called as a steady state of temperature. If you start heating the rod at its one end, then what will happen? Heat energy will be absorbed by the particles present at first end. Then temperature of first end starts increasing, and temperature of first end will be increasing from room temperature up to certain level. Then heat energy will be transmitted from its one region to another region without bodily movement of particles. This is called as the conduction. Conduction will be, one can say, occurred in the body, and heat energy will be reached to the one end to another region. Now after certain time, what will happen? Initially temperature of first end will be more and temperature of second end will be less, because before starting the process of conduction, temperature of the entire rod at first end it will be more, then it will be decreasing, and at last end it will be less. One can say this is a variable temperature state. But after certain time, transmission of heat energy takes place from its one region to another region, and temperature of entire body becomes constant. This is called as a steady temperature state. Steady means constant. That means if you consider any solid body, if you heat the solid body at its first end, then temperature of first end will be starting or will be increasing, and temperature of second end will be, one can say, less. This is called as a variable temperature state. That means when temperature of body is different at different regions, then this is called as a variable temperature state. And when temperature of entire body is constant at its all regions, then it is called as a steady temperature state. There are two temperature states are present. First one is a variable temperature state. That means when temperature of body is different at its different regions, then it is called as a variable temperature state. When temperature of body is constant at its all regions, it is called as a steady temperature state. Now we have to discuss what is the law of thermal conductivity. Now if you consider one solid rod, and the rod is heated at its one end, then heat energy will be transmitted from its one end to another end. Heat energy will be transmitted from its one region to another region. Now this rod is having cross-sectional area A. We are heating the rod at its one end, means temperature of first end is different, temperature of second end is different. We are transmitting the heat energy for time t, and d the distance between two ends or 2 points. Then you have to define the law of thermal conductivity. Law of thermal conductivity states that quantity of heat energy or amount of heat energy flowing from one end of a conductor to another end is directly proportional to the cross-sectional area of a rod. If rod is having more cross-sectional area, more diameter, more radius, then cross-sectional area will be more. If cross-sectional area is more, then more amount of heat energy will be transmitted, because more number of particles will take part in the process of conduction. More particles they will absorb the heat energy from source, and transmission will be more, then quantity will be more. That means if you increase the diameter or if you increase the area of rod, then quantity of heat energy transmitted from one end to another end will be increased. This is a natural observation of everybody. If you take small rod, if you heat up to 100 degrees Celsius, if you measure the quantity of heat transmitted to another end, we will get particular calories. If you increase the cross-sectional area of your rod, and if you heat the rod at its one end, and if you measure the quantity of heat reached for the same time and for the same temperature condition, you will get more amount of heat energy transmitted at another end, because if you increase cross-sectional area of a body, then